Okay, so we're going to talk about a little bit more about what we were talking about in class today, and that's measurement of angles. So first off, some vocabulary associated with angles. An angle is in standard position if its vertex is at the origin. So this drawing here is an angle in standard position, and you can see that the vertex of the angle, the point where the two rays that make the angle come together, that's at the origin. And then the other requirement is that the initial side has to be on the positive x-axis. So if you think about the way that you make an angle, you have these two rays. One of them is stationary, it doesn't move, and the other one moves to create the angle. So in this case, this side moved, this ray moved to make the angle. The ray that moves is called the terminal side, and the ray that's stationary is called the initial side. And an angle in standard position has its initial side on the positive x-axis. Okay, so a couple of different ways that you can measure angles. If you measure an angle using counterclockwise rotation, you'll use positive units for that. So for this angle that's drawn up here, if we say the angle was created by opening the ray up this way, that would be a positive measurement that we would make. However, if we rotate clockwise, then we use negative units. So this same angle up here could be measured several different ways, but two of them would be positive that we just showed you, or if we said that it was created using clockwise rotation, we'd use negative units. You'll often see Greek letters like theta, beta, alpha, or capital letters for angles. And the amount of rotation can be measured in degrees or radians. And so that's kind of what we're trying to get to here, is the different ways to measure. So if we look down here, when you're measuring an angle in radians, the angle measurement is equal to the arc length divided by the radius. So when you look at this angle inside of this circle, the two rays that make the angle intersect the circle, and between those rays is what's called the arc length. It's a part of the circumference. And when you divide that arc length by the radius, you get the angle measurement in radians. And so we saw a little bit about that today with our Twizzler activity. So if I apply that formula here, arc length divided by radius, I can figure out the size of these two angles. So in this first one, the arc length is 5 and the radius is 2. So the angle measurement would be 5 divided by 2 radians, because you divide arc length by radius. So same thing here, we've got the arc length is r and the radius is r. So the angle measurement would be r divided by r, or just 1, right? R divided by r is just 1, so 1 radian. And this is what we saw in our activity today, that when the arc length is equal to the radius length, the angle is 1 radian. Right? So 1 radian is the measure of a central angle whose arc length has length r. Okay, so now we're going to get down to the meat here. What we want to be able to do is convert between what we're familiar with, which is degrees, and radians, which we're going to become more familiar with. So if we follow this same idea here, that the angle measurement in radians is arc length divided by radius, 1 revolution, 1 time around the circle, well, that arc length would be 2 pi r. Because 1 time around the circle, that's the circumference of the circle, and circumference is 2 pi r. So you can see the r's cancel, which means that 360 degrees is the same as 2 pi radians. So from that, we can get a couple of formulas that will help us convert between the two. When you want to convert from degrees to radians, you multiply by 2 pi over 360, so that you can cancel out the degrees and get radians. And when you want to go from radians to degrees, you do just the opposite. You multiply by 360 over 2 pi, so you can cancel the radians and get degrees. So we're going to do a couple of examples of converting here. So first off, if I want to convert negative 225 degrees to radians, so I'm going degrees to radians, so I'm going to use this first formula. So negative 225 times 2 pi over 360. We want to leave our answer in terms of pi. So when you go to put this in the calculator, you're not actually going to type the pi into the calculator. So I'm going to show you how to do that. So let's see here. If I go in on my calculator, I'm going to type in negative 225 times 2 over 360. I'm not going to type in the pi. So it's negative 5 over 4. So now when I go back over here, okay, so let's see. See if I can get back over here. Okay, so if I go back over here, this would be negative 5 pi over 4. All right. So now you try doing 50. Okay, so when you converted 50, you should have gotten 5 pi over 18. So now we're going to go the other way. Now we're going to convert something that is in radians back to degrees. So let's look at how you would do that. All right, so the next one says convert negative pi over 3 to degrees. So to convert from radians to degrees, we said the formula was to multiply by 360 over 2 pi. So we're going to take negative pi over 3 and multiply by 360 over 2 pi. So notice that the pi's cancel out, and that leaves an understood 1 on the top here. So on the top we're doing negative 1 times 360, and on the bottom we're doing 3 times 2. So in your calculator, what you can write is this, or what you can type in is this. We're doing negative 1/3 times 360 over 2. The pi's canceled out, so we don't need to put the pi's in, and we get negative 60. Right? So this one we would put negative 60. All right? So try the 3 pi over 4. Okay, so should have gotten 135 on that one. Okay, so the next thing we're going to talk about are some special angles called quadrantal angles. And these are just angles that don't lie in one of the 4 quadrants. They're actually on either the x or y axis. So the first one would be 0 degrees. If your angle is completely closed, no rotation at all, that's 0 degrees. And we know if we rotate all the way around, that's 360 degrees. So now you can kind of divide things up. We know that halfway around would be 180. A quarter of the way around would be 90. And 3/4 of the way around would be 270. So then these same angles in radians, we know that 0 would still be 0 in radians. No rotation at all, still 0. And we know that all the way around is 2 pi. So from that we can figure out some of the others. Halfway around would be 1 pi, or just pi. A quarter of the way around, halfway between 0 and pi, would be 1/2 pi, or we call it pi over 2. And then 3/4 of the way around, halfway between 1 pi and 2 pi, would be 1.5 pi, or 3 pi over 2. So those are called quadrantal angles. Okay, so now we're going to try to sketch a couple of angles. 120 degrees is going to be 30 degrees past 90, right? So if we start here, this is our initial side. Our terminal side would be 30 degrees past 90. And because it's positive, we use this counterclockwise rotation. We rotate up from the x-axis. So this would be about 120. Negative 45, though, we would still start on the positive x-axis, but our rotation would be clockwise, so we would go down. And we're going to go down about 45 degrees, so about halfway into this 4th quadrant here. So this would be negative 45. Most people don't have too much trouble with degrees. You're somewhat familiar with it. Where we run into a little bit of difficulty is when we start talking about radians. So if you're comfortable with fractions, radians don't normally give you any trouble. But if you're not, radians will help you get better at fractions for sure. So if you think about, if you look at the fraction part, because all of these are in terms of pi that we're dealing with here. So let's look at the fraction, 5/4. 5/4 is more than 0, it's more than 1/2, it's more than 1, but it's not more than 3/2. If you think about 5/4, that's like 1.25. 3/2 is 1.5. So it would be in here, right? If we do our positive rotation here, this would be about 5 pi over 4. Negative 3 pi over 2. If you think about what positive 3 pi over 2 looks like, that can kind of help with this one. Positive 3 pi over 2 would be if we went all the way around to here. So negative 3 pi over 2 would be if we went same distance but the opposite direction. It's actually the same as pi over 2. So negative 3 pi over 2. We're going to talk about this some more tomorrow, measuring out these angles, especially with the radians. People tend to have a little bit of trouble with that. Okay, last thing, and I know I've gone over my kind of 10-minute limit that I've set for myself, but what you're going to do here is you're going to tell what quadrant each of these is in. And the degrees you probably have a little bit easier time with than the radians. But again, if you'll just pay attention to the fraction part for the radians, ignore the pi, they all have pi in them. Like 7 pi over 12, if I just look at 7/12, 7/12 is more than 0, it's more than 1/2 because 1/2 would be 6/12. So 7/12 is more than that, but it's not more than 1. 1 would be 12/12, so it would be in quadrant 2. Okay. So you'll just go through here and see if you can figure out what quadrants all these are in. Remember that with the negative rotation, if you can figure out where the positive angle would go, like here positive 3/4 would be over here in quadrant 2, we would rotate this way. Negative 3/4 would be just the opposite. It would be the same kind of distance. We'd go 2 quadrants, but in the other direction. So this would actually be in quadrant 3. Okay, so go through here, see if you can figure out what quadrants all these are in. I'm going to put the rest of the answers up, and you can check yourself. Okay, so I've put up what quadrants the rest of these are in. The last two, negative 180, remember positive 180 is like this. So negative 180, same distance, opposite direction. It would be like this. Either way, you end up over here. And that's on an axis. So that's what we call a quadrantal angle. It's not in a quadrant. So I just put quad for quadrantal. Same thing happens with 3 pi over 2. 3 pi over 2 is this way. That is another quadrantal angle because you're on the y-axis here.